Hello, Algebra 2. In this lesson, we are going to review the transformations in a plane. And the transformations are just ways to manipulate the equations of a function and change the way the graph looks. We're going to go through the basic transformations you learned in Algebra 1, starting with the easiest one to understand, the vertical shift. So a vertical shift happens for a function when all of its y values are increased or decreased by the exact same amount. So let's say this turtle is a relation, and all of his y values are something, and if I want to shift the turtle up 5 spaces, I need to take all of its y values and add 5, and then the little turtle moves up, right? And similarly, if I want him to move down, subtract from the y values. So then if I look at a function and I want to test it out, and see it visually in action, right, I'm going to pick a function that is easy to see a transformation. Don't pick linear, because they're just lines. You need something that changes direction. Perfect example of a function that's going to change direction on you is the absolute value. So I'm thinking I just have to add 5 to all the y values. Right now, all the y values are generated by the absolute value of x. So if I just tack on a plus 5, then my graph should move up, right? So let's just double check to make sure. Graph it. That's the plane parent function. Vertex at the origin. Adding 5 to it makes the vertex 5 on the y-intercept, or at least better. And it does, like magic. So if I want to shift a function up or down, I have to take the function itself and then add some value to it. So for example, if f of x is equal to the absolute value of x, then a shift up 2 units is going to be g of x equals the absolute value of x plus 2. All right? So I have to add to move it up, and if k is negative, turns into a subtraction, moves down. So now let's talk about the horizontal shift, which means moving a graph left or right. And this was the transformation in Algebra 1 that causes the most trouble because it seems backwards. But let's look at the parent absolute value function to figure out the y's of the horizontal shift. So if I just look at this basic graph, the vertex of this absolute value function is at the origin. It's at 0, 0. And if I just wanted to move this graph over 5 spaces to the right, I'm moving the vertex over 5 spaces to the right. And this vertex also happens to be a 0 of the function. So I can think of this particular graph's transformation to the right 5 spaces as a shifting of the 0 5 spaces. And if you remember about what zeros are, it's where the y is 0, so I'm looking for the x-intercept, right? So I need to manipulate my equation to get an x-intercept of 5. Now I know it's not adding or subtracting 5 at the end of the function because that just makes all the y values bigger or smaller. I need to shift the x-intercept. So that means I have to manipulate inside the function rule, in this case the absolute value. If it were quadratic, it would have to be inside of parentheses being squared. Same thing with cubic, so on and so forth. I need to manipulate inside the absolute value to change the x-intercept, or where the 0 is. So if I want my 0 to be 5, then inside the absolute value I have to have x minus 5. Because now at the value of 5, the y value is 0, and my graph moves to the right 5 spaces. And so if I wanted to move it to the left 5 spaces, I have to add 5, because now in this case, negative 5 makes this statement 0, and I'm going to get a graph that shifts to the left. So what you want when you're in Algebra 1, you want the vertical and horizontal shifting to match up, meaning if plus 2 moves the graph positively on the y, you want a plus 2 inside to move it positively on the x, but it's actually the opposite. Once again, you can think of it in terms of shifting the x-intercept. So the horizontal shift is done within the function rule. So inside f of x, you have to subtract off whatever value you want. And so this means a shift of h units. And it's good to show both the positive and negative example in this case. So saying if f of x is equal, once again, to the absolute value of x, g of x being the absolute value of x minus 4 is, remember, to the right 4, and h of x being absolute value of x plus 4, oopsie, means to the left 4. Now let's talk about the reflection across the x-axis. So what I want to do in this case is reflect the little turtle across the x-axis, right? And so anything that was positive value needs to be negative. Anything that was negative needs to be positive. So if I go back to my original absolute value equation, the original function, all of the values are positive except for that vertex, which is non-negative, and I want to literally reflect them all over the x-axis. So that means I want them all to be literally the opposite sign, and the only way to do that is to, of course, make the entire function value negative. And now when I graph it, all the points are reflected through the x-axis. So a reflection through the x-axis is quite simple. All I need to do is take the opposite of the function value. So now we're on to the last transformation, the stretch or shrink. And in Algebra 1, it had we used different words to describe it. So if I was talking about a linear function, we were talking about how do I change the steepness of a line. If we were talking about the absolute value function, we were talking about how to make it like thinner or wider. Same with the parabolas. This is the stretch or shrink. Oftentimes it's referred to as the dilation, and it is related to the dilations in geometry where scale factors are involved. Remember, scale factors are numbers you can multiply the dimensions of a figure by to change its size. Same thing with functions. So I'm going to multiply my function value by some constant, and that's going to affect width. So if I look at my basic absolute value function and I want to make it skinnier, so I have my basic absolute value function and I want to make it a lot skinnier, what I need to do is I need to scale my y values up so that they're actually higher than they were before. So instead of maybe having, the 0.11, I want the 0.12, or I want the 0.13, or I want the 0.110, right? So in order to do that, I need to multiply the entire function by some value that's greater than 1, like 2. And so when I graph it, all my y values are twice what they were before, which gives the illusion of a skinnier graph. So if I want to make it appear that my graph is wider than the previous graph, I have to look at the function and think, well, I need my y values to actually be below what they are now, so I have to make them smaller. And remember, negatives don't make them smaller, negatives make them the opposite sign. So to make them their magnitude smaller, I have to multiply it by a fraction. So instead of having the 0.11, maybe I want the point to be 1 and then 1/2. And then I want 2 and maybe 1, and 4 and 2. So I want them to be half of what they were before, in which case I need to multiply the function by some number that's between 0 and 1. And I graph that, and I get a function that's much wider in the case of the absolute value. And you can think of the wider as being less steep, or you can think of it as being stretched horizontally. It all depends on your perspective and the language you choose. So now why don't you write all this down? The absolute value of A needs to be greater than 1 if you want to make a graph thinner, steeper if it's a line, or vertically stretched. And if you want it to be wider or less steep or horizontally stretched, you need to multiply it by a factor between 0 and 1. Remember, absolute value. Because the sign doesn't matter. The sign does something entirely different. It does that reflection across the axis. And the way I always remembered the endpoints was that if I multiply a function by 0, like the function's gone and it's just a horizontal line. And if I multiply it by 1, it's the exact same graph. So in between exact same graph and horizontal line, I get something that's wider or horizontally stretched. Now there is one transformation we did not do in Algebra 1 that is exclusive to Algebra 2. and that is, what does f of negative x do? So in your next in-class activity, we're going to look at what this does to a function.